Let's look at example 7. It asks us to find the area enclosed by the line y equals x minus 1 and the parabola y squared equals 2x plus 6. So, first thing, I'm going to try to sketch a little graph of them. Y equals x minus 1 is easy. It's a line with slope 1 that crosses the axis at -1. So it looks something like that, except straight. And then the parabola y squared is 2x plus 6. So y squared equals... Now, you've probably drawn sideways facing parabolas more recently than I have. It's been a while since I've done that, but I do know that it's opening to the right because I have a positive number sitting next to my y squared, and I could plug in, if x is equal to 0, then y squared is equal to 6, so it's going to cross the axes at plus or minus square root of 6, which is somewhere a little bigger than 2. And if y is equal to 0, then 2x plus 6 must be equal to 0. So -3 is equal to x, 1, 2, 3, and I said somewhere a little bit bigger than 2, a little bit bigger than 2. And I need to find where they cross. Certainly cannot tell from my less than beautiful picture. So we'll set them equal to one another. Now we have to solve them for x and set that equal to one another, because we are going to integrate with respect to y. Why, you ask, do I want to integrate with respect to y? If I were going to integrate with respect to x, I would have to find this intersection point, and I would have to find this area minus this area, and add it to this area minus what's underneath this parabola minus what's underneath the line. No, I'm going to just imagine turning the paper sideways. I'm going to integrate with respect to y instead of respect to x. So, if y squared is equal to 2x plus 6, then y squared minus 6 is equal to 2x. So y squared over 2 minus 3 is equal to x. If y equals x minus 1, then y plus 1 is equal to x. So now I set the x's equal to one another. Y squared over 2 minus 3 equals y plus 1. Y squared over 2 minus y minus 4 is equal to 0. I don't like that fraction. I'm going to multiply everything by 2. So y squared minus 2y minus 8 is equal to 0. So y minus 4 times y plus 2 is equal to 0. Y is equal to 4. Y equals -2. So this is y equals -2. If y is equal to -2, x is -1. And this is y equals 4. If y is equal to 4, x is equal to 5. just because I like to label my points. But I'm integrating with respect to y, so my limits of integration come from y. WRT with respect to y, so my limits of integration come from y. So I have the integral from -2 to 4. Now, when we're integrating with respect to x, it's top minus bottom, because positive is top and negative is bottom. When we are integrating with respect to y, it's right minus left, because more positive stuff is to the right and more negative stuff is to the left. So my right one is y plus 1 minus my left, which is y squared over 2 minus 3. Integrating with respect to y works exactly like integrating with respect to x. So I'm going to do the integrating, and we'll meet back here and compare answers. Arithmetic, arithmetic, 18. Okay. 2 more. Give number 12 a try. See if you can sketch a graph of it and then find the area between the two curves, and we'll do number 20 together. It looks a little different. So try number 12 on your own. How did it go? Set them equal to one another. Actually, first I solved for x. I also sketched a little graph. I plugged in y equals 0 to figure out where it crosses the axis. I knew that it was opening to the left because if I put them on opposite sides, x and y on opposite sides of the equal mark, then one of them is going to be negative. If they're both positive when they're on opposite sides of the equal mark, then it opens to the right. But if one's positive and one's negative, it's opening to the left. Okay, so sketched my little graph, set them equal to one another, found out they cross when y is equal to -6 or 2. The parabola is further to the right, so it's parabola minus line, integrate, arithmetic, answer. Voila. Okay, let me get my questions back up here. We want to integrate with respect to y. Number 20, we have x equals y to the 4th power, and y equals the square root of 2 minus x, and we're looking at when y is greater than 0. So first off, x equals y to the 4th power. Not too hard to graph. It just looks like a sideways facing parabola with a flattened out vertex. So a fat bottom parabola facing to the right. Now, square root of 2 minus x. We can logic our way through this one. Square root of x looks like this. If we put a minus sign inside of it, that flips it around, and adding 2 underneath the radical shifts me 2 units. So I am 2 units to the right, something like that. Now, I don't think I did a very good job of drawing this. I think it should actually be more like this. because let's set them equal to one another and see where they cross. I'll fix the picture later. So I need to have x's because I'm going to be integrating with respect to y. So this one's already ready already. This one's way not ready. So y squared is equal to 2 minus x. And that means that y squared minus 2 is equal to negative x. So x is equal to 2 minus y squared. Now let's set those things equal to one another. I'm going to pause for a moment. Set this equal to y to the fourth. So y to the fourth plus y squared minus 2 is equal to 0. So y to the fourth plus 2 times y squared minus 1 is equal to 0. And that should be squared. This one has no real solutions. Y squared equals 1, y equals plus or minus 1, but y has to be greater than 0 because we want it to be bounded by y equals 0, square root, y equals square root of 2 minus x, and x equals y to the fourth power. So that's actually sitting there at 1. My area is going to be the integral from y equals 0 to 1 of the further to the right function, and the further to the right function is 2 minus y squared, and the left function is y to the fourth power. So 2y minus y cubed over 3 minus y to the fifth over 5. Evaluated from 0 to 1 gives me 2 minus a third minus a fifth, which is 30 over 15 minus 5 over 15 minus 3 over 15, which is 30 minus 5 minus 3, 22 over 15. Now, I could also do this one with respect to x. If x is equal to y to the fourth power and y is greater than 0, then y is equal to x to the 1/4 power. And I already have this one as a function of x. From 0 to 1, I'm looking at the area underneath x to the 1/4 power. From 1 to 2, I'm looking at the area underneath square root of 2 minus x. Add 1 to the exponent, divide by the new exponent. This one, u is equal to 2 minus x. Du is equal to negative dx. U evaluated at 2 is equal to 2 minus 2, which is 0. U evaluated at 1 is equal to 2 minus 1, which is 1. So this is the integral from 1 to 0 of negative u to the 1/2 du. And this is evaluated from 0 to 1. So that's just going to be 4/5. This is going to be add 1 to the exponent, divide by the new exponent. So u to the 3/2 over 3/2 evaluated from 1 to 0. So I have to plug 0 in first, but it's negative. So it's going to be 0 minus negative 2/3. So 4/5 minus 2/3. Actually, 4/5 plus 2/3 because it was minus minus. That gives me 12/15 plus 10/15, 22/15. So you could do it either way. Sometimes it's really hard to do it one way or the other, so it's good to know that you can do it both ways. Alrighty, you are all ready for area between two curves. Go forth and web assign.